guys, in this class, let's now talk the relationship between your gravitational constant, which will be capital letter G, and your small g, which is your gravity on the earth. And this is our lesson 4. Now, let's go. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your JAMB and WAEC, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app, where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. What's the relationship between gravitational constant, which is capital letter G, and your acceleration due to gravity on the earth, which is what, small g? Now, let's prove that. First and foremost, take note that we said, let's first of all go, what is force on the earth? We know that force is equal to mass times acceleration. Therefore, force is equal to what? mg. This m, I can call it me, which is mass of the earth. Are you seeing that me is just normal mass of the world? This is gravitation on the earth now. Now, we know that according to Newton's law of gravitation, it says that the force of attraction between two masses, m1 and m2, is proportional to the product of their masses and proportional to their square of their distance apart. Therefore, we can see that force, so let's call this equation 1. We can say force is equal to Gm all over what? All over r squared. Are you seeing that Gm over what? Over r squared. So we can also name this, let's call this the mass of the earth too. Are you seeing that? So let's call this our what? Equation 2. Now everybody, equating equation 1 and equation 2, we can say that mg, which is this, is because this, both of them are force, they are equal. So we can equate both of them is equal to G m all over what? R squared. Are you seeing that? So we said that this mass, whether mass of the earth, we just mean mass of the earth, this mass can cancel this mass. Is that correct? So we can now say that our G is equal to capital letter G m all over what? R squared. This is the relationship between capital letter G and this is the relationship between acceleration to gravity G and what? Capital letter what? G. G is equal to Gm all over R squared. Very, very what? Simple. Do you understand? First, we said that force, I'll take that again, force is equal to mass times acceleration, and according to Newton's universal law of gravitation, F is equal to Gm all over R squared. So we equated both of them and say mg is equal to Gm all over R squared. So one mass cancels one mass, so it now becomes G is equal to Gm all over R squared. Please, for these things two are past question, these ones are past question. You see that which of this is correct? Forget it, prove it. It's very, very what? Simple. So this is it again. Wait for that to say that force is equal to mass acceleration and G is equal to G, which is mass of the earth. And we now say that if we equate both of them, therefore this is mg, this is this. So we're equating this to this now, because this is equal to the force is equal to force. So we're equating that. From here now, we say that this mass will cancel this. Either you decide to put earth or you don't put earth. So from here now have G is equal to what? To m. G is equal to Gm r squared. Do you understand that? Where your G is constant, gravitational constant, r is distance, G is acceleration due to gravity on the earth, m is the what? Is the mass of the earth. Do you understand that? If you say you understand that, what's now the relation of G on different places on the earth? From that equation we solve, let's go back to the equation. From the equation we solve, we said that G is equal to Gm all over r squared. So what's the relationship between G and distance? Look at it. Both of them are inverse proportional. It means that if the acceleration to gravity is increasing, the distance will be what? Reducing. So if the distance is reducing, acceleration to gravity will be what? Increasing. Are you seeing that? So because of this now, if we have the equator, let's say this is the earth, this is the center. This point is far from the center. This point is far from the center. This point. So acceleration at this point will be highest, while acceleration at the center will be what? Minimum. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login.
Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you have put in your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type here? Your John what? 123. You can decide to view it to yes or, and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there, and then you view it, and then come to select education. You are preparing for JAMB or WAEC. In select education, there are 4 plans there. University, that's for people that are in university, probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for JAMB and WAEC, click WAEC JAMB post UTME, right? As the select education. Select level. You are not preparing for post UTME, you are preparing for JAMB and WAEC, right? Okay, click on the what JAMB and what WAEC. And then create your account. 2 seconds. Plus, you don't enter. It will load, and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning. Why? Because of this relation, G is equal to 1 over what? R squared. So that's what we are trying to explain, that variation at different places of the earth, variation of G at different places of the earth. Number 1, we say C is equal to 1 over R squared. We are taking all of that into be constant, and that's how we say they are 1. We can see that when gravity increases with decreasing what radius. As gravity, look at it, as relation to gravity is increasing, radius, which is the distance, is what is decreasing. Do you understand? Therefore, it is minimum, gravity is minimum at the equator and maximum at the poles. At the equator, which is the center, it is minimum, but at the poles, it is what maximum. And also note this point, third point, the acceleration to gravity decrease with increasing altitude. Still saying the same thing, because if the altitude is increasing, acceleration to gravity will be what? Decreasing. But if acceleration to gravity is increasing, altitude will be what? Will be decreasing. Do you understand? Now, give me the Earth. This is the Earth. The Earth is spherical in shape. You can see that as if we have acceleration to gravity, where will it be maximum? It will be strongest at the pole. These are the poles. These are the pole. So it is maximum at the pole, but it is minimum at the what? At the center. So it is greater than here, but here it is what? Less than. So maximum at the pole, minimum at the center. And that's not for gravitational field. All field, even magnetism. If it's a magnet, please think about the magnet is north-south. It is strongest at the pole, weak at the what? At the center. If you have electric field, positive and negative, let's say it's an electric field, it is strongest at the pole, but weakest at the what? At the center. Even gravitational field, all the force field, all the vector field, gravitational, all of them are strongest at the pole, weakest at the what? At the center. Do you understand? Now let's take WAEC 1998 question. See the question says that determine the mass on the Earth if the radius of the Earth approximately we're given radius of the Earth, we're given a gravitational constant, we're given J. How do we solve this? First of all, let's give out the parameters. Bring out your parameters, you know what to solve. We're giving radius of the Earth, so R is equal to 6.38 times 10 raised to the power 6 meter. Ensure your unit must be in meter, radius must be in meter, mass must be in kilogram. We're giving G, which is gravitational constant, to be 6.67 times 10 raised to the power minus 11. We're giving small g to be 9.80 meter per seconds minus. What are we asking for? Mass. So we know that small g is equal to g m all over r squared, right? The relationship between large d and small g.
So from here now, what is now G? G was going to be 9.80 is equal to 6.67 times 10 raised to power minus 11 times you're looking for mass all over distance, which is 6.38 times 10 raised to power 6 or square. So from here now, what to be M? M will now be cross multiply. That's 9.80 times 10 raised to power 6 times 10 raised to power 6 all square all over 9.8. So yeah, bring out a calculator, let's punch. Now if you do this, you're going to have 5.980 times 10 raised to power 24 kilogram. Now don't forget, this is not 9.8. Look at it now, we cross multiply now. That would be what? 6.67. Let's put here 6.67 times 10 raised to power minus 11. Please ensure to use your calculator to confirm to know whether I'm what correct, but that's the answer.
So when it comes to creating an account, right, this is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or, and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for JAMB or WAEC. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for JAMB and WAEC, click WAEC JAMB post UTME, right? As the select education. Select level. You are not preparing for post UTME, you are preparing for JAMB and WAEC, right? Okay, click on the what? JAMB and what? WAEC. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning.
Quickly, let's take the next question. We're giving you 2004 question 17. We're told that the Earth is 4 times the size of the moon and the solution to gravity on the Earth is 80 times that of the moon. The ratio of the mass of the moon to that of the Earth is, we're given option A, given option B, we're given option C. First of all, they say the ratio of the masses. What are their masses first? Masses will be M1 all over M2. That will be their masses. Or you see M1 ratio M2. So first of all, let's get what formula that has to do with mass. We know that G is equal to GM all over R squared. Cross multiply mass. Now the mass will now be equal to G R squared. That is for M mass 1 now to now be G1 R squared 1. Is that correct? While for mass 2 will now be equal to G2 R squared 2. Now look at now. If you look at this, we can say for the mass 1 and mass 1 will now be equal to. They didn't talk anything about the initial, so we're going to take all of them as 1, 1. Since they didn't talk anything about initial. Anytime they don't give about initial, always take it as what 1. So I'll take our solution will be 1 times 1 square, which will be equal to what 1. That means the mass at M1 is equal to what 1. Let's get for mass at M2. We're told that acceleration to gravity is 4 times. That means the acceleration is 4. That's acceleration is 4. The Earth is 4 times the size of the moon, and the acceleration to gravity is 8 times that of the moon. So acceleration due to gravity is 80. Are you seeing that? So from here now, we can now say that acceleration is 80. That's our G2. What is this distance? 4. That's times 4 all word square, which will give us 80 times 16. That will give us 1 to 80. That's the mass 2. So what will that be their ratio? Ratio will now be mass 1 all over what? Mass 2, which will be what? 1 all over 1 to 80. That will say they are saying 1 ratio 1 to 80. Is it the option? Making option B to become the what answer. Do you understand? It's just a relation question. I told you how to relate. If you don't understand it, pause it, take it all over again. JAMB 2015 question 1. The question says that a satellite moves at a circular orbit of radius 4r. That's the radius of the Earth. The acceleration due to gravity, the acceleration of the satellite in terms of g is a. We're giving 4 by g. We're giving that. What relationship between acceleration to, we're giving distance. So what is the relationship between distance and g? We said g first is equal to g m all over r squared. So this is the relationship between them. So therefore g is equal to 1 all over r squared. Is that correct? So from here now we can say that g, if you make that of the formula, let's call this constant. So we can say k is equal to g r squared. So this will be g1 r squared 1 is equal to g2 r squared 2. Since we're giving, they say the satellite move as circular 4r, the acceleration will be, so we are going to take our g1 and r1 to be what? 1. That means g1 will be equal to 1, r1 will be equal to 1. I told you they don't give you, take them as what? 1, 1. Do you understand? So from here now, we can now say that, that's, from this formula now, we can say what's g1? That's 1 times 1 all squared is equal to, what's our g2? G2 is what we are looking for. They say the acceleration of the satellite to be, this will be G2 times is the distance 4 times. That's 4 all squared. So that will practically give me 1 is equal to 16G. Is that correct? So what will be, that's the G2. What will be G2 now, which is G will be equal to 1 all over what? 16. So G will be equal to 1 over 16, which is the same thing as saying G all over what? 16. Making option C to become the answer. Do you understand that? It's just simply what? A relation what question. Or from here you cross multiply to give 16 all over what? Over G.
Now that you have created your account, right? For you to start learning, what do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they are all there for you, right? What do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it, immediately you click on it, you see all the classes will display history of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cells immediately. Hello, friends. Your class will start playing for you. It will start playing for you easy and direct. And what happened? You can even choose to make it full screen, right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use NightSub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. all you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following, the answers are there. Number one answer is B. Why is the answer B? It is explained for you in details, every singular thing, and then you are following your classes. You are done with that. You come to the next, you see your notes, everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out, you too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your WAEC cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosomal. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
Now let's see JAMB 2009 question 1. The question says that the value of mx and y respectively in the expression in universal gravitational constant is, we solved this question in dimension, but I'll still solve it again. Now, taking that, we said what relationship between small g and big G? G is given as gm all over what? R squared. So from there now, we're looking for G. So G, capital, if you make G, will give you what? G R squared all over m. Is that correct? What was G? G is acceleration. Abi, what's acceleration? Acceleration is meter per seconds minus 2. Right? That's meter. That's LT minus 2. What is distance? R is L. That will be L. So what is M? M is in kilogram. So this same thing saying G will now be equal to, that's LT minus 2 times L2 all over capital letter what? M. Is that correct? So this will now be equal to, this will be L. This is 2. This is 1. That will give me L3. This will be T minus 2 all over M. From indices, this will be M raised to power minus 1, L3 T raised to power what? Minus 2. And the question is if we have M, T, where we have X, Y, and Z. X first will be minus 1. What will be Y? Y will be equal to what? 3. And what will be Z? Z will be equal to minus 2. That's 1 minus 1, 3, and 2. That's option B. Making option B to become the answer. Do you understand that? Pause it, take it over and over again. Now, next class, we're going to talk about weight and weightlessness still on this topic. And that will be our lesson 5. But for now, peace out. A lot of questions in the notes. So when you are done, you go to the notes. But finish the class first. Let's finish the class before we talk about the note. For now, peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store,
and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.